Hmm. Okay, hello. In the previous video, I demonstrate a bit about the back end of the Apex Trade application. Okay, and now I'm going to explain the associated Postgres database for that same application. I'm going to explain the structure of the application database, what tables I have used, what kind of procedures, triggers, views I have used, okay, how many schemas are there. So basically, if you can see the right side, left side of the panel, okay, you can see that this is the database. And in that database, we have three schemas. Okay, I've come up with the conclusion that I only need maximum three schemas, one for authentication, one for order, and one for wallet. If I'll expand the authentication schema, if you'll see, we have role table, which is, or should I say, configurational data, okay, which consists of distinct role values, ID and name. Okay, as you can see, I've added two roles, okay, admin and user. Secondly, we have user table, the main table, okay, where we have encrypted hash password, which is decrypted by JWT token during login and registration. We have username and the ID, and we have a junction table for user and role, where user ID and user role are both mapped on one-on-one. Okay, and we also have a function which basically I created whenever like a new user has been registered with the help of Swagger or Postman or whatever HTTP request. The what happens is that first the user entry is done on the user table. Okay, where did it go? Okay, so as soon as hmm, I'll check on that. Maybe there's still a problem with the query. So basically, what it does, it triggers to add a new user. Okay, whenever the registration happens, there's another trigger I will explain you in a moment. So basically, what happens is that I'm not handling this junction table from the back end, from the Spring Boot. I'm handling this junction table from this SQL trigger. So what happens is that whenever the user is newly created, the trigger is triggered, and it also does the entry in the user role, as well as there is another trigger which is also triggered on the same user entry, but this time it is, instead of setting the role, it sets the basic wallet with the amount. Okay, as we also have like I've created a procedure. Okay, this is also programmatically done in Java in Spring Boot, but just for the showcase, I have also implemented the same thing in as a stored procedure as well, demonstrating my procedure development skills. So what it does is basically when a buyer and the seller is matched, so basically it collects the amount, put it into different wallet, and vice versa. So basically it's the trade happening in the real time. Okay, if there is any issue, balance is insufficient, it will throw exception, then it will catch in the string boot. Okay, so coming back to the authentication, in the authentication, okay, we have cleared it up. This is the role, this is the user role, and we can ignore this because this is basically associated with the Flyway migration tool integrated in Spring Boot. Basically, whenever I run the migration script and update the model, I mention it in the script, okay, with the version. So basically, whenever I explicitly push my migration, SQL migration, so it does the entry here to keep the synchronicity, to maintain the synchronicity, basically, so that no extra or no wrong execution happens. This table exists in all different schemas to maintain their own isolated environment and migrations. So coming to the second schema, which is order schema, in this we have main table order. Okay, in that we have order ID, username, symbol, side, if it is a buyer side, if it's seller side, price, status. We have three status: filled, pending, and cancel. Okay, filled is when the transaction or order has been completed, pending when the new order is still in the pool, and cancel if the user decides to cancel the order. Okay, and okay, it shouldn't be here. I don't know why it is here. It's wrong. Then comes the trade. Okay, once the both parties, buyer and seller, make the trade, it does the entry in this table as well with the buyer ID and the seller ID along with the quantity as well. It's just like a general ledger where we keep all the transaction record. This is a transactional table, hot table, we can say that. In this schema, we have different, I've created different views. Okay, like for example, if you want to view the trade history, I've created a query to know, uh, have fast execution for dashboards and everything. We have trade velocity, okay, like what kind of trade has happened on what volume. And last but not least, we have whale trade. I didn't know about this concept. I was just trying to come up with better queries and for the financials, and I came up with this word whale trade. That means like a big chunk of trade uh, by buyers and sellers. Okay, not the small transaction, the big transaction. And last, the wallet. In this, we have um, simple is that for every user we have two entries. One is for USD and one is for Bitcoin. And again, as whenever the new user comes, he gets 100k USD and zero point 0.7 Bitcoin. It's not very specific, it's just a random. So this is the overall backend database architecture of this trade app. Thank you for listening.